We are working on 2.0b. I'm going to do the topics a little bit out of order. I wish they would order them differently, but I don't really have control over that. So here we have an equation that has two binomials, y plus 1 times y minus 9 equals 0. And we know how to multiply those together to get a quadratic. But I want to know which y values make this equation true. So if I had a times b equals 0, what do you know about a and b? One of them has to be 0. So if a times b equals 0, then you know at least one of them is 0, or both. If a equals 0, then 0 times b is 0, no matter what b is, and vice versa. And if a and b are both 0, then it's still true. So we're kind of doing that same thing in a little bit of an expanded form. If this is a and this is b, then we know one of two things has to happen. Either y plus 1 is equal to 0, or y minus 9 is equal to 0. And then, of course, they could both be 0. How do we solve those? We just subtract 1. So y equals -1. Add 9. Y equals 9. What does that mean? Well, watch what happens when I plug in -1. I get a 0 there, and I get -10 there, and 0 times -10 is 0. If I plug in 9, I get 10 times 0, which is 0. Okay? Okay. Ooh. Let's not do that one yet. Nope. Let's not do that one yet. Here we go. So we have the same sort of equation. It just is in a little bit different form. So if I had x minus 3 times x plus 2, and I multiplied that together in the box, x plus 2, x minus 3, and then 2 times x would be 2x, -3x minus 6, and I simplify down, I get x squared minus x minus 6. So I have taken factored form and multiplied it into quadratic form. Well, now we're going to go backwards. We're going to take this equation and turn it into that equation. And we do that using the box. So I put in v squared. This one goes right here. And this one goes right here. And I recommend that you write this out. Then you multiply those together. V squared times -6 is -6 v squared. Now I look through all the factor pairs of 6. What goes into 6? 1 and 6, 2 and 3. Can I use one of those to create a positive 5? But it also has to create a -6. So I could do 2 plus 3, or I could do 6 minus 1. Which one's correct? No. So I have to be able to build both of those. 2 plus 3 is 5. And 6 minus 1 is 5. But what is 2 times 3? It's positive 6. What is 6 times -1? -6. So you have to have both versions. You have to have the multiply version and the addition version. So we're going to choose this one. And it also has to have a v squared in there. So we're going to write 6v and negative 1v. Does everybody understand that? So this times this is that, and this plus this is that. That will be the same rule every single time we do one of these problems. Okay? Now, if I look here, what do those share? What do they have in common? A v. And if I take out a v from each of those, what's left? A v and a plus 6. Now, if I take a v out of each of those, then I have a v left over and a negative 1. And then one thing you should always do to make sure that you did it correctly is, what is this number times this number? It's that number. Now I have my factors. V plus 6 and v minus 1. So, if the problem says factor, then you're done. That is the factored form of this quadratic. If it says find the roots or solve, or if the equation says equals 0, then you have to go one step further. So when will this equation equal 0? Well, either v plus 6 is equal to 0, or v minus 1 is equal to 0. So here I subtract 6. Here I add 1. So v is either negative 6 or 1. Okay, let's do another one. All right. Same idea. I draw the box. X squared, 24. What's the next step? Multiply those together. 24 x squared. Then I write down everything that goes into 24. 1 and 24, and I recommend doing them in order. That way you won't miss one. 2 and 12, 3 and 8, 4 and 6, and 5 doesn't work, and that's the end of the list. Okay. Will one of those make a negative 10? Well, we have two of them again, right? 2 minus 12 is negative 10, and 4 plus 6 is negative 4 minus 6 is negative 10. So which one works for both? Can you make a positive 24 with a 2 and a 12? No. Well, you can. 2 times 12. But if this is positive and this is positive, then you cannot make a negative 10. So you have to be a little bit careful, because a lot of times there are two possible answers. So this is not it. How do I build a negative 10 using a 4 and a 6? Negative 4 and negative 6. So I put in negative 4x and negative 6x. Does it matter which is which? No. It'll just change the order of your answers, but it'll still work. All right, we look at the top row. What do those have in common? X. And now if I take out an x from each of those, then I'm left with x minus 4. And if I take out an x from each of these, then I get x minus 6. And then I always double check, is this times this equal to that? Yes. So my factors are x minus 4 equals 0 and x minus 6 equals 0. Okay. Add 4, add 6, x is 4 and 6. Do you need to see another one of those? Do you guys remember this from last year? Yeah? Okay. Now we'll do one of the harder problems. Oh, let's not do that one yet. Let's do this one. Okay, this just says factor. So when it says factor, we don't have to do the equals 0 part. Okay, I draw the box. I put in 3z squared in the first box and 20 in the last one. Multiply those together, 60z squared. Now, on the last three problems I did, you might be able to do those in your head. But this one has something that makes it more difficult. Do you notice what's different about this one? So that's a good point. It does not equal 0, and the equal 0 just means find the roots. So in this case, when we get to the parentheses, we're done. Okay. What else is different about this? We have a 3 here, and that complicates things. So on the last couple problems, you could probably do those in your head with enough practice. But if there's a number in front of the biggest exponent, the leading coefficient, then you need to use the box because it's really, really hard to do these in your head. All right, factors of 60. 1 and 60, 2 and 30, 3 and 10, 4 and 15, 5 and 12, 6 and 10, 7 doesn't work. That's it. 8 doesn't work, 9 doesn't work, and 10 we already have. Okay, can I use one of those to make a 17z? This one. And the 17 is positive, so it will be 12z and 5z. Now look carefully at the top row. What does the top row share? 3 and a z. So I'm going to take out a 3 and a z. If I take out a 3 and a z from the first one, I'm left with z. If I take out a 3 and a z from the next one, I'm left with 4. And if I take a z out of here, I'm left with 5. So my factors are z plus 4 and 3z plus 5. And then you're done. But what if it asks you to find the roots? Then you would say z plus 4 equals 0 and 3z plus 5 equals 0. We're going to subtract 4 here. Z is negative 4. This one's a little bit harder. And then divide by 3. So z also equals negative 5/3. Okay. All right, one more. Same basic idea here, but again, something's different. What's different about this one? It equals 3 instead of 0. Excuse me. And it is one of the harder problems because the leading number is a 4 and not a 1. So how do I fix this to make it equal to 0? Right, I'm going to subtract 3 so that this side cancels. And I get 4u squared minus 11u minus 3 excuse me, equals 0. Draw the box. Put in 4u squared minus 3. Multiply those together. Negative 12u to the second. Now I go through all the factors of 12. 1 and 12, 2 and 6, 3 and 4. Can I use one of those to make a negative 11? 1 minus 12. So 1u and negative 12u. These share a u. Excuse me, guys. And if I take a u out, I get 4u plus 1. And on the left side, I get u minus 3. Am I done, or do I need to find the u equals? Yeah, this one wants you to solve. So 4u plus 1 equals 0, and u minus 3 equals 0. Subtract 1, and I get 4u equals negative 1. Divide by 4, and u is negative 1/4. And then add the 3, and u equals those two numbers. All right, that's it for 2.0b. Get to work.